Hello and welcome to our lesson on factoring polynomials. This is going to cover several sections from our text, section 4.3, 4.4, 4.5, and 4.6. So this is going to be a comprehensive video on factoring polynomials where I'm going to cover all of the topics that you would cover in those sections. So what I would like to start with is going through what I call the factoring checklist. So first step, factor out says if you have any common factors, you have to factor them out, and that has to happen first. Once you factor out a common factor, if there is one, then you're going to consider how many terms there are. So if there's two terms, you've got two options where you could have the difference of two squares, or you could have the sum or difference of two cubes. So before I move on, I want you to notice that for squares, you can only handle a minus. If you have cubes, you can handle a plus or a minus and get that to factor. Or if there's three terms, you could have what's called a standard trinomial, which means the coefficient of the x squared term is 1. Otherwise, if you have a lead coefficient, that's going to require a different technique, and I prefer the 3R method. There are other techniques for factoring trinomials with a lead coefficient, but I prefer the 3R method. And last, if you have four terms, you only have one option there, and that is factor by grouping. And that covers the checklist. Now, what we're going to do is go through examples where I'm going to cover each one of these in order. So we're going to work our way down the checklist as we go through the examples. So I'm in section 4.3. And from this exercise set, we're going to look at problem number 1 first. And then later, as I move to a different section, I'll state that before I do the example. Number 1, the instructions say factor. Now, it doesn't indicate how to factor. It just says factor. And that means that you would need to start at the top of the checklist and work your way down, applying any appropriate factoring techniques. So step number 1, we're going to factor out if there is a common factor, and it turns out that there is a common factor. What I would like you to notice is that 6a squared can be written as 3a times 2a. And let's write that in green, 2a. So 3a times 2a gives 6a squared, and I'm breaking that down into factors so that you can hopefully see what's about to happen. Next, 3a can be written as 3a times 1. Anything times 1 is itself, so 3a times 1 is 3a. And now do you see I've color-coded it so that you can see that these two terms have a common factor of 3a. And so what we're going to do is we're going to factor that out, which means we're going to do the distributive property in reverse. So the 3a, that is the common factor, is going to be factored out, which means I'm going to take that from both of these terms, and then whatever's left goes in the parentheses. So do you see, if I were to do the distributive property, I would get back what I had. So that is how factor out works. And so that is factored completely. Next example, number 7 from section 4.3. Here again, they say factor. We're looking for the GCF, which is the greatest common factor. In other words, I want to know what is the biggest thing that will divide evenly into both terms. Well, between 4 and 12, the biggest number that goes into both of those is 4. So I can divide both of those by 4. And then if I can consider the variables, if they both have the same letter, I'm going to take the smallest power. So between x squared and x is the least amount. That's what I can factor out. They do also have a common factor of y, and the least amount is just a y. So that is my GCF, my greatest common factor. Now I need to figure out what's going to be left over, and I do that by dividing. So 4x squared y divided by 4xy, the 4's will cancel, the y's will cancel, and I will have 1x left over, minus. Then again, if I divide by 4xy, 4 goes into 12 3 times. The x's cancel, and I will have 1y left over. And that is factored correctly. It is also factored completely because the remaining binomial inside is not the difference of squares, right? These are not squares, and it's definitely not cubes. So that's where you stop. Next, on number 25, I wanted to demonstrate that sometimes you got to be careful when you factor out. Here we have a binomial where it's already written in descending order. The exponents go down in order. And so that makes the negative 3y squared the lead term. And when you factor, if at all possible, you want that lead term to be positive. So we're going to look for a common factor, knowing that we're going to have to factor out a negative, whatever it is, in order to get that lead term to be positive. So what goes into both 3y squared and 24y? Well, I know 3 does. So 3 is going to be the biggest number that we can factor out of the coefficients. And since they both have a y, I can take the smallest exponent, and that means I'm going to be able to factor out a y. So there's our GCF. And then to divide, negative 3 divided by negative 3 is positive 1, which we don't have to write that. Y squared, take away y, leaves us a y. Remember, we're factoring out a negative, so that means that this sign will have to be negative, because then when we distribute, a negative times a negative will give us our positive back. So 24 divided by 3 is 8, and the y got factored out, so that y is going to disappear, and that is our final answer. That is factored correctly, but it's also factored completely. And if I want to, I can distribute the negative 3y back in to make sure I get back what I had, to make sure that I factored out correctly. Okay, the next problem we're going to look at is number 33, and this problem is taken from section 4.6. I had to jump all the way ahead to 4.6 to get to a difference of squares problem. And remember, I said that I'm moving down this checklist in order, so that means I may have to jump around in the sections. Number 33, we've got p squared minus 49. And remember our checklist, you have to start at the top and work your way down. So the first thing I have to ask myself is there a common factor that I can factor out? Well, between p squared and 49, there is no common factor other than 1, and factoring out a 1 is not going to make any difference. So there's nothing to factor out. So then I move down the list, and I notice that there are 2 terms. And then I say, well, could this be the difference of 2 squares? So I'm going to check. P times p makes p squared, so that's a perfect square. 7 times 7 makes 49. That's a perfect square. And I do have a minus, which is required to do the difference of 2 squares. So I have verified this is the difference of two squares. Now I've got a little recipe that has 3 ingredients for factoring the difference of squares, okay? The 3 ingredients are parentheses, different signs, fill in the blanks. So your first step is always going to be parentheses, 2 sets of parentheses. Second step, different signs. Difference of squares always has different signs. And then the third ingredient, fill in the blanks. P and P times P is P squared. 7 and 7, 7 times 7 is 49. And then if we were to do the FOIL method, we could check and make sure that we get back what we had. So in order to check this factoring, you would need to FOIL it. And that is factored correctly. It's also factored completely. Next, number 43. Here we have a binomial. The instructions say factor, so it doesn't really tell me how to factor, so I'm going to use my checklist. Starting at the top, I need to know, is there a common factor that I can factor out? Well, I notice that both of these terms do have an a, so I am going to have to factor out an a. But between 4 and 49, there is no common factor other than 1. So the most I'm going to be able to factor out is a. Remember, that has to be done first. So that's going to leave me a 4a squared minus 49, right? If I divide both of those by a, each factor loses a factor of a. And then I'm going to consider what's left over to see if it'll factor further. Well, 4a squared minus 49 is the difference of two squares. And I can't stress enough how important it is to make sure you've got a minus there for the difference of squares. So the a comes down. Remember, the recipe is parentheses, different signs, fill in the blanks. Okay, so what two factors make 4a squared? Well, that would be 2a and 2a. And then the two numbers that make 49, well, that's no fun because we did that back in number 33. So we know that that's 7 and 7. And then we're going to put a box around that because we're done. That is factored completely, and it's also factored correctly. Next, number 38. We're going to look at one more difference of squares example. Here we have a binomial. There's two terms. They do not have a common factor. There's nothing to factor out. And so remember, in the checklist, if there's two terms, the first thing you consider is the difference of two squares. So we're going to ask ourselves, are these perfect squares? Well, AB times AB would make A squared B squared. 9 times 9 is 81. So these are perfect squares. And so that means that we can use our recipe for the difference of squares, which says parentheses, different signs, fill in the blanks. AB times AB makes A squared B squared. 9 times 9 is 81. And then that is factored completely. Even though this 9 here is a perfect square, this AB is not. So if this AB would have been another perfect square, since that is a minus, then you would need to factor that further. Please understand, sometimes there's more than one step of factoring, and you have to consider if it'll go further. But this is factored completely, and we're going to put a box around that because we're done. Okay, for the next example, I couldn't find one in the text that I like, so I'm just going to call this my example. I made it up. And this is one of those things that you've got to look out for, okay? There are two terms. The instructions say factor. So we're first going to look for a common factor. Is there anything we can factor out? Well, they don't both have an x. Nothing divides into 9 and 64 evenly. So there is no GCF, no common factor to factor out. And so then we say, okay, I've got two terms. Could this be the difference of two squares? Well, I would like to point out 3x times 3x, that is 9x squared, so that is a perfect square. 64 is 8 times 8, that is a perfect square. And so you might be thinking, well, yeah, that's going to factor, but the sign in the middle is plus, not minus. So if you go back to the checklist, you can see that for squares, you have to have a minus or it won't factor. So we call this the sum of two squares, and the sum of two squares is prime. So the word prime is what you write if your polynomial will not factor at all. If there was a GCF that I could factor out, then this would not be prime. If you can do any factoring at all, it's not prime. But if you cannot even take a single step of factoring, especially if you have the sum of two squares, the correct answer to write is prime. Prime means it doesn't factor at all. All right, next example, number 72. Here we have c cubed minus 64. The instructions say factor, so obviously we're going to check for a common factor, which there is none. And then we're going to say, well, I've got two terms. Could this be the difference of two squares? Well, 8 times 8 is 64. That is a perfect square. But c cubed is not c squared, and so that is not a perfect square. So this is not going to be the difference of squares. So if we look at our checklist under two terms, the next thing to check for is cubes. Could this be the sum or difference of two cubes? Well, let's check. Cubes means something times itself 3 times. So c times c times c is c cubed. Do you see that? And 64 happens to be 4 times 4 times 4. So this is the difference of two cubes. And just to point out, cubes can handle a plus or a minus sign. That means that you can factor cubes if it has a plus or a minus, either one, unlike the squares that you can only factor with a minus. So I have a recipe for this. It also has 3 ingredients, and the first ingredient is parentheses. Now you need to notice that the second set of parentheses is a little bit wider. Since it's cubes, we got to extend that set of parentheses because back here we're going to have a trinomial. So that's the first step. First step is parentheses. Second step is we're going to throw in some soap. Soap, S-O-A-P. And soap is going to give you the signs, okay? So what does SOAP stand for? Well, it stands for same, opposite, always positive. SOAP for the signs. So the first sign is going to be same as the problem. Guess what? The next sign is going to be opposite. Opposite of minus is plus. And the last sign is always positive. So SOAP, again, SOAP is for cubes and dirty people. And SOAP gives you the signs, okay? One more time. Same, opposite, always positive. And for the third ingredient, we're going to fill in the blanks. So in the first two blanks, we're going to come up here and take one of each factor. That's going to give us a C and a 4. And then for the last 3 blanks, we're going to square, multiply, square. So that means we're going to take the first term and we're going to square it. Then we're going to take both of these terms and multiply. C times 4, that is 4C. And for the last blank, we're going to square the 4. 4 squared is 16. And we're done. That is now factored completely. And number 77, I thought we should do one more perfect cubes just for fun, and also to show you the difference between the difference and the sum of the cubes. So, first step, if you're going to factor, remember you got to look for a common factor. Between these two terms, there is no common factor other than 1. And so then if we go back to the checklist, remember you have to consider, is it perfect squares or is it perfect cubes? And so this time we have perfect cubes. So to write that down, that's going to be 2x times 2x times 2x. That'll make 8x to the third. 27 is 3 times 3 times 3. And if your numbers here are bigger and you're not sure how to tell if it is a square or a cube, what you can do is use your calculator to check. So the calculator has a square root button, so I can see if it's a perfect square there. The 27, whoops, does not square root nicely. So then I'm going to check and see if it's a cube. And so that means I want to do the cube root, which is shift square root 27. And that tells me that that is a perfect cube. 3 times 3 times 3 is 27. Let me demonstrate one more time. Let's say that the number here is 343. That is a huge number. Not many people know that's a perfect cube. But if they do give you 343, with the calculator you can check and see, it is a perfect cube. So the calculator can come in handy checking these numbers to see if they're perfect squares or perfect cubes. Now for the recipe, we're going to have parentheses. Next, let's throw in some soap. Same opposite, always positive. So the first sign is always same as the problem. Next sign has to be opposite of that. And the last sign is always positive. Soap for the signs. Soap is only for cubes and dirty people. And the last step, step number 3, we're going to fill in the blanks. So we're going to take one of each factor, 2x and 3, for the first 2 blanks. And then we're going to square, multiply, square. So 2x squared, that would be 2x times 2x, which is 4x squared. Okay, there's our first blank. And then for the middle blank, we're going to multiply these two together. 2x times 3, which gives us 6x. And for the last blank, we're going to multiply 3 times 3. This guy multiplied 3 times 3 gives me 9. Got that? Square, multiply, square. And you're done. That is factored completely. And we haven't talked about trinomials yet, but just to go ahead and give you some insight for later, when you're doing the sum or difference of cubes, the trinomial that's left will always be prime. Okay, this trinomial will never factor further. Number 33, 38, 72, 77, 91, all of these problems have come from section 4.6. So number 91, we have 2 terms. So the first thing to look for if you're factoring is a common factor. And it turns out that 5 and 40 can be divided by 5. So that is a common factor. And they both have an x, so I can take out the smallest power, which is x squared, but they do not both have a z, so this is going to be it for the GCF. Now, to figure out what's left over, remember you simply divide. So we're going to divide both terms by 5x squared. Here the 5's are going to cancel. And for the x's, 5 take away 2 leaves me a 3. So I'm going to have an x cubed left. And then 5 goes into 40 8 times. X squareds are going to cancel completely, and that will leave me the z cubed. So that takes care of the factor out step. Now we need to look in the parentheses and see if that will factor further. And it just so happens it does, okay? So this is the difference of two cubes. X makes x to the third. 2z times 2z times 2z makes 8z to the third. And so we're going to need to factor this remaining polynomial as the difference of two cubes. So the 5x squared comes down. By the way, that is the most common mistake students make, is they will drop this as they go down. So just remember the 5x squared has to stay there all the way down, no matter how far down you go. And for the cubes, remember the recipe has parentheses, soap for the signs, same, opposite, always positive, and we need to fill in the blanks. So in the first two blanks, we're going to take one of each factor. We're going to have an x and a 2z, and then we need to square, multiply, square. Square, multiply, square. Now 2z times 2z gives me 4z squared, and that is it. That is factored correctly, but listen, it's also factored completely. All right, for my next example, notice I've jumped to number 1, and I've also jumped to section 4.4. So now we're going to shift gears and look at factoring trinomials. That doesn't mean that you can skip the checklist, okay? Remember the checklist, you have to start at the top and work your way down. So we are going to have to check for common factors. And then remember, for this section of problems, we're going to be focusing on the three terms, the trinomials. So looking at this problem, all three terms do not have a common factor. So I can't factor out, but it is a trinomial. And guess what? I've got a recipe for trinomials that also has 3 ingredients. The first ingredient is parentheses. Second ingredient is read the signs. Now, to read the signs, you look at the last sign first. If this is plus, you have to look over here, and that's what they both are. Okay? So if the last sign is plus, both of the signs are going to be this sign. And for the third ingredient, we now have to fill in the blanks. So what does it take to make x squared? Well, it takes an x times x. And for the last two blanks, I'm going to need two numbers that multiply to make 36 and add to make 13. That is the process for figuring out what the two numbers are. Okay, one more time. Multiply to make 36, add to make 13. And that would be 4 times 9. 4 times 9 is 36. 4 plus 9 is 13. And that is done. That is factored completely. So for number 3, I realized that when I did number 1, I didn't really guide you through the checklist completely. So let's go back to the checklist. Here, factor out has to come first. And then since we're looking at 3 terms, remember there are 2 choices here. So what a standard trinomial is, a standard trinomial is one that has an x squared where the lead coefficient is understood to be 1. You can also have trinomials that have a lead coefficient where the lead coefficient, say, is 4 or some other number other than 1, and then we have a different technique for that. So you do need to check to see if you have a standard trinomial or if there is a lead coefficient. So the first example here, this was a standard trinomial because the lead coefficient was 1. Here again, number 3, we have another standard trinomial. And so again, the recipe is parentheses and then read the signs. So if the last sign is plus, you have to look over here, and that's what they both are. Plus at the back means the same. These are going to be the same, and they're both going to be whatever the first one is. And then for the third and final ingredient, fill in the blanks. T times t gives me t squared. And I need to have numbers that multiply to make 15, that also add and make -8. And that's going to be 5 and 3. 5 times 3 is 15. -5 and -3 makes -8. And that is factored completely. All right, next example, number 9. We have another trinomial. We do not have a common factor that can be factored out. And this is a standard trinomial since we have a lead coefficient of 1. So we're going to go ahead and apply the recipe for standard trinomials, which is parentheses, read the signs. This time we have a minus at the back. And when the last sign is minus, these two signs are different. You don't even care what the first sign is this time. When the last sign is minus, these have to be different. And it doesn't matter what order they're in. You could put minus plus or plus minus, either way. Third ingredient, fill in the blanks. We're going to have p times p to make p squared. And then for the last two blanks, I need numbers that multiply to make 54. And this time they need to subtract to make 3. And it does need to make +3. So numbers that multiply to make 54 would be 6 times 9. And 9 minus 6 is 3. So this is going to have to be a 9 and a 6. Again, 6 times 9 is 54. Check. 9 minus 6 is +3. Do you see that it matters what order the 9 and the 6 go in? And that is factored completely. Next, number 23. Hey, here's something we haven't seen yet. Notice that this polynomial is not in descending order. And so the first thing you need to do if it's not in descending order is rewrite it. So we're going to say -y cubed plus 4y squared plus 32y. And so we need to rewrite that in descending order, the exponents going down 3, 2, 1. Now we can see that the lead term is negative and the lead term really needs to be positive. So one of the things we're going to have to do is factor out a negative. I also notice that all three terms have a y. So to follow the factoring checklist, we are going to have to factor out the GCF first before we can even consider how many terms there are. Here we go, factoring out -y. That's going to leave me with +y squared minus 4y minus 32. So notice that everybody lost a y. 3 becomes 2, 2 becomes 1, 1 becomes none. And did you notice that every sign changed? When you factor out a negative, it's super easy to just remember change the signs. Now we need to consider the stuff that's left over inside the parentheses. And so here we do have a standard trinomial. So we're going to try to factor that further. So we have parentheses. We need to read the signs. Minus at the back makes them different. And fill in the blanks. Y times y to make y squared. And numbers that multiply to make 32, that subtract and make -4. And that is going to be 4 and 8. Get it? 4 minus 8 is -4. So the placement of the 4 and the 8 is critical, that you get this middle term. 4 times 8 is 32. And now that is factored completely. Okay, next example, number 31. We have another trinomial. Oh, and remember the checklist says factor out has to come first, right? So we need to look for a common factor that we can factor out before we consider if our trinomial has a lead coefficient. Very important to stress that. So if you're just looking at this and you're not being careful, you might say, uh-oh, this trinomial has a lead coefficient. I need to use a different technique. No, you need to follow the checklist. So 2, 8, and 90 all can be divided by 2. So we are going to have to factor out the 2, which means we are going to have to divide everybody by 2. And that'll leave me with x squared minus 4x minus 45. Then we need to consider the trinomial that's left over and see if it will factor further. Don't forget that the 2 needs to come down. So we drop the 2. And our recipe, again, parentheses, read the signs. Minus at the back makes them different. And fill in the blanks. X times x makes x squared. And I need numbers that multiply to make 45 and subtract to make -4. 5 times 9. And the 5 has to go with the plus, because 5 minus 9 does make -4. So again, placement of the 5 and the 9 is critical. And 5 times 9 is 45, and that is factored completely. And one more example for the standard trinomials, number 27. And again, if I haven't stressed it, all of the examples that I've done all the way back up to number 1 here, number 1, 3, 9, 23, 31, 27, all of these have been from section 4.4 in the text, just so you know where they came from. Here we have a standard trinomial. Remember, standard means that it has a lead coefficient of 1. So the first thing we need to check for is a common factor. All 3 terms do not have a common factor, so I'm not going to be able to factor out. And so then I'm going to see, well, will this factor? So we're going to start with parentheses. We're going to read the signs. Plus at the back means look over here. And that's what they both are. So they're both minus signs. And fill in the blanks. X and x make x squared. And now for the fun part. I've got to have 2 numbers that multiply to make 7 and add to make 3. Yeah, well, the only numbers that multiply to make 7 are 1 and 7. Since 7 is a prime number, the only factors are 1 and 7, and those numbers definitely do not add to make 3. So in this case, this trinomial is actually not going to factor. And do you remember what we say if the polynomial cannot factor at all? Right, the answer is prime. So sometimes you cannot factor even a single step, and those polynomials will be prime. And that is the only acceptable answer there. Okay, for my next example, you'll notice that it's labeled number 1, so I had to skip ahead to section 4.5 because we're skipping ahead in the checklist. Now we're going to look at trinomials that have a lead coefficient. Oh, and if I scroll up, I'm going to get to teach you my patented 3R method now. Okay, it's not really patented, but it is a cool technique. What we have here is we have a trinomial with a lead coefficient. Remember, the checklist says factor out has to come first. The problem is 3, 14, and 5 do not all have a common factor other than 1. And so there's no way to factor out and get rid of the 3. So this is considered a trinomial with a lead coefficient. We're going to do the 3R method, okay? Now the 3 R's are remove, replace, and reduce. So, first step, we're going to remove the lead coefficient of 3. We're going to remove it, and that's going to give me an x squared minus 14x minus, but now listen, when I remove it, here's what I'm going to do with it. See that? I'm going to take it to the back and multiply. 3 times 5 now is 15. So that is the remove step, where you remove the lead coefficient and multiply it times the constant. Then I'm going to treat this trinomial as a standard trinomial, which we just did a lot of those, so you should be pretty proficient with the technique. And the technique, the 3 ingredients are parentheses, read the signs, minus at the back makes them different, and fill in the blanks. X and X make x squared, and I have to have numbers that multiply to make 15, that subtract and make negative 14. And that is going to be 15 and 1. Notice the 15 has to go with the minus, because 1 minus 15 gives me negative 14. So now that I have that factored, now I can do the second R, which is replace. Okay, so what did I remove? The 3. Now I need to replace it. And notice when I replace it, I have to put it back in front of each x. That is the replace step. And then I need to reduce. Okay, so we'll do this in purple. Reduce says that you look in each set of parentheses and reduce the 2 numbers if possible. So 3 and 1 will not reduce, so the 3x plus 1 comes down, but 3 and 15 will reduce by 3, and so I need to reduce those. So that'll give me x minus 5. And once you do all 3 steps, remove, replace, and reduce, what you have is the final answer. Now, if I wanted to, I could FOIL and check. If I do the FOIL method, I better get back what I had, or it's not factored correctly. So just so you understand that, if this is a test situation, and you need to make sure that this answer is correct, you can FOIL it and see if it gives you the problem back. Next example, number 13. Here we have another trinomial with a lead coefficient. And please don't forget the factoring checklist. You have to do first things first. 18, 51, and 15. If they all have a common factor, you have to factor it out, and it has to be done first. So they do have a common factor of 3. 3 will divide into all 3 of these numbers evenly, and they don't all 3 have an A, so the GCF is 3, and I do have to factor that out first. So when you factor out, you're dividing. 18 divided by 3 is 6. So that's going to leave me 6a squared minus 51 divided by 3 is 17. So that's going to be 17a. Plus 15 divided by 3 is 5. So now that we factored out the GCF, we need to consider the stuff left over in the parentheses and see if it will factor further. And I think it is going to factor again, but since it has a lead coefficient, again, we're going to need to do the 3R method. So the first R is remove. We're going to remove the 6. And remember, we take that and multiply times the back. So that's going to give me a squared minus 17a plus 30. That is the first R, remove. And then I'm going to factor the standard trinomial that's left over with parentheses. I need to read the signs. They're both going to be minus and fill in the blanks. A times A gives me a squared. Numbers that multiply to make 30, that add and make negative 17, that's going to be 15 and 2. 2 times 15 is 30. 15 and 2 is 17. Now it's time for the second R, which is replace. So the 6 that I removed now has to be replaced. And don't forget that it goes in front of each A. You got to replace the 6 in front of each A. And then it's time for the third R, which is reduce. So, can 6 and 15 reduce? Yes. They can reduce by 3. Can 6 and 2 reduce? Yes, they can reduce by 2. So in each set of parentheses, whatever the numbers can be reduced by, they need to be reduced. And please don't forget that that 3 has to continue to come down. So 6 divided by 3, that's 2a minus 5. 15 divided by 3 is 5. And 6 divided by 2, 3a minus, now 2 divided by 2 is 1. And now that is done. That is the 3R method again. And remember that at the end, if you want to, you can FOIL and check. Here, if I FOIL this, I should get this back. Next example, we have number 33, which we do have a trinomial. The instructions again say factor. And so what I need to do first is I need to consider all 3 terms and see if there is a GCF that needs to be factored out. And I just realized that this lead term is negative. Don't forget we need to factor out a negative to take care of that. So what can divide evenly into 8, 8, and 30? I think the GCF there is 2. Notice that they all do have a t. So I'm going to be able to factor out a t also. And I need to take care of this negative. So our factor that we're going to factor out is negative 2t. And then we need to figure out what's left over. So remember, when you're factoring out a negative, all 3 signs are going to change. So you don't really need to think about that too hard. 8 divided by 2 is 4. 3 take away 1 is 2. So there's going to be a t squared left. Next, we're going to have a plus 4t and a minus 15. Remember, all 3 signs have to change, and everybody loses a t. Now then, we need to consider what's left over. We do have a trinomial with a lead coefficient, which means we're going to need to demonstrate the 3R method again. So the negative 2t comes down. We're going to remove the 4, which is going to give us t squared plus 4t minus, now what is 4 times 15? That is 60. And then we're going to factor the standard trinomial that's left in the parentheses. So the negative 2t comes down. We're going to have parentheses, read the signs, and fill in the blanks. T times t makes t squared. And I need numbers that multiply to make 60 that subtract and make positive 4. Let's see. Numbers that multiply to make 60 would be 6 and 10. And I think the 10 needs to go with the plus. Okay, so check it. 10 minus 6 is positive 4. 10 times 6 is 60. So I have the right numbers there. So if you're keeping score here, we did the remove. Now it's time to replace. So what did we remove? We removed the 4. Now we need to replace it. And then we need to reduce if we can. So 4 and 10 will reduce by 2. 4 and 6 will also reduce by 2. And so my final answer is negative 2t times 2t plus 5 times 2t minus 3. And that is factored completely. And for the last example from section 4.5 here that we've been working in, we're going to look at number 49. We have a trinomial with a lead coefficient. But what I'd like to point out here is that this is a special case. If you are mathematically aware and can recognize a special case when it occurs, it can make your life easier. So here's what I mean by this is a special case. Notice that the lead term is a perfect square. 3x times 3x makes 9x squared. Notice that the last term is also a perfect square. So what we have here, not only is this a trinomial with a lead coefficient that does, by the way, doesn't have a GCF to factor out, but this is what we call a perfect square trinomial. You do not really need to do the 3R method here since it is a perfect square trinomial. All we need to do is do our 3-step trinomial recipe, which says parentheses, read the signs. Here they're both going to be negative, and we're going to fill in the blanks with our perfect square factors. 3x and 3x, 5y and 5y. Now for these perfect square trinomials, I would highly recommend that you FOIL and check. So I am going to demonstrate this, the FOIL and check process, to show you how you make sure you have the right answer, okay? So first, 3x times 3x, we know that is 9x squared. On the outside, we're going to have a negative 15xy. On the inside, another negative 15xy. And last but not least, negative times a negative makes a plus 25y squared. And then remember, we need to CLT. We need to combine like terms. We get negative 30xy. And so you can see that when we FOIL, we get our 9x squared minus 30xy plus 25y squared. So we do get our problem back, which means that we do have it factored correctly. And so let's put a box around that because that is the answer, and we verified it is correct. Okay, for our next problem, I have jumped ahead to number 47, but I've also jumped back to section 4.3. So this problem and the remaining problems will be from section 4.3. And if I could scroll back up all the way to the top, remember what we're doing is we're working on the factoring checklist, working our way all the way to the bottom. So everything that I've done so far has been in order. And we're to the last concept, 4 terms factor by grouping. So for number 47, here we do have 4 terms. You do need to consider the fact that there may be a GCF, okay? So just because we have 4 terms doesn't mean you can skip the factor out step. But there is no common factor, so I am going to demonstrate factor by grouping. Here we're going to group the first 2 terms together and the second 2 terms together. And then we're going to start over and say, okay, what can I factor out of the first group? What do they have in common? Well, I can factor out a y squared from the first group, and that will leave me y plus 8 if I factor out a y squared. And then in the second group, what can I factor out of negative 5y minus 40? Well, notice they are both negative, so I need to take out the negative. And 5 will divide into each one of those terms. So I'm going to factor out negative 5, which is going to leave me with y plus 8. Now, it is absolutely critical to remember when you factor out a negative, remember both of those signs change. So if you're wondering, well, why is this a plus? It's because I factored out the negative. It is also critical to notice that the stuff in the parentheses does match. If you are doing factor by grouping and the stuff in the parentheses doesn't match, you either A, screwed it up, or B, it won't factor by grouping. So the next step, no, we're not done. The next step is to look at these 2 terms and now say, what do they have in common? Well, they both have a y plus 8, and those are factors, and we're going to factor that out. So the y plus 8 is going to get factored out, which means that they're going to lose the y plus 8, and I'm going to have left y squared minus 5. Now that is the factor by grouping done completely. Factor by grouping has 2 steps. You factor out the common factors, and then you factor out again. Then when you reach this step, you need to consider, will either one of these factors factor further? And the only one that looks promising is the second factor. Here I have the difference of 2. Well, it's almost the difference of 2 squares, except the 5 is not a perfect square. So that was close, but that's not going to factor as the difference of 2 squares, which means that this is factored completely. All right, next, number 49. Here we have another 4-term polynomial. And the very first thing I notice is that it's not in descending order. Notice here's the x cubed, and then here's the x squared. So the first thing I really should do is rewrite this in descending order. So that's going to be 24x cubed minus 36x squared plus 72x minus 108. Now that it's in descending order, now I need to consider greatest common factor. What will divide evenly into all 4 numbers? And there may not be one, but in this case, I notice they're all even. So I know at least 2 will go into all of them. But it turns out the biggest common factor is 12. And that may not be obvious to everybody. You may look at that and divide by 2. and then notice that more stuff can come out. So you do need to take out the greatest common factor. And again, that may require 2 or 3 steps, making sure that you take out as much as you can before you move down your checklist. So here we go. We're going to have 12. And then what is going to remain in the parentheses? 12 goes into 24 2 times. 12 goes into 36 3 times. 12 goes into 72. I'm not sure. Let's check the calculator. 72 divided by 12, that's 6 times. And 108 divided by 12 is 9. All right, so that takes care of the GCF, the factor out step. Now, what we can do is factor by grouping. Since we have 4 terms, we're going to factor by grouping. The 12 does need to come down. And in the first set of parentheses, I can take out an x squared, and that will leave me 2x minus 3. Now, maybe I better color code this, okay? There we go. So this parenthesis is this parenthesis, and then the blue set of parentheses is from the factor by grouping. So next, between the 6x and 9, I can factor out a positive 3, and that's going to leave me 2x minus 3. And then if I close my parenthesis, this parenthesis corresponds to this parenthesis. Now remember I said when you do factor by grouping, the stuff in the parentheses has to match. And then since it does, we're going to factor that out. Okay, so again, remember the 12 comes down. And now we're going to factor out the 2x minus 3. Factoring that out is going to leave me with x squared plus 3. And since this is not the difference of 2 squares, that means that this is factored completely. And there's another example of factor by grouping that also required factoring out the GCF. Number 61, this is from section 4.6. Here we do have 4 terms, 1, 2, 3, 4. And I thought I'd throw this in for fun. This is one of those special cases where you have 4 terms, and the standard factor by grouping technique, which says group them 2 at a time, doesn't work. So what we're going to show, hopefully, is that you kind of have to have a mathematical eye for recognizing these cases, okay? So notice that the first 3 terms, if I just look at those, it looks like a standard trinomial. So what we're going to do is we're going to factor these 3 terms as a standard trinomial and just bring the -9 down. Okay, so we're going to have, for our trinomial, we're going to have parentheses. We're going to read the signs. They're both going to be plus. And we're going to fill in the blanks. Okay, so what does it take to make a squared? A times a. And what does it take to make b squared? B times b. Now, if I FOIL that, you're going to notice that we do get the 2ab term from the FOIL method. So that means this is factored correctly. Now if I bring down the -9, notice that these 2 factors are identical. That's a plus b times a plus b, which can be written as A plus B quantity squared. And now all of a sudden, I have the difference of two squares. Okay, do you see this is a perfect square? 9 is 3 times 3. That is a perfect square, and I do have a minus. So now to factor this as the difference of two squares means that we're going to have parentheses, different signs, and fill in the blanks. So this factor, A plus B, goes in the first position, and the factors of 9, 3, and 3 go in this position. And this is weird looking, but this is the way this factors. That is one of those special cases that doesn't come up very often, but there's an example of how that particular special case works. And that's going to do it for this lesson. So if you have any questions or And that's going to do it for this lesson. So if you have any questions or comments about anything that I've done so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.